So, future engineers, let's continue with our discussion. No? Last time on the single degree of freedom system on its equation of motion. So last time we have already formulated the equation of motion of a one-story building. And for the last topic, we tried to subject the one-story building with a vibratory ground motion or an earthquake excitation. So we arrive with this formula. We have the mass times the response acceleration plus the damping coefficient times the response velocity plus the lateral stiffness times the lateral displacement is equal to the negative m or the mass times the ground acceleration. U double dot g of t. So we have here a structure under ground uh, excitation with an acceleration moving on both lateral direction, on the left or on the right. Now we have already discussed that this motion, this earthquake being applied on the building can be transformed into a stationary one-story building like this one, but the effects of the earthquake motion is resolved into an applied dynamic force or P effective as a function of T. Then we eventually will have this function. We have the mass times the response acceleration or U double dot T plus the damping coefficient times U dot of T or the response velocity plus the K times the lateral displacement U of T is equal to this one. And then this one that the force effective is just equal to the negative M or mass times U double dot G of T or the ground acceleration. So we have here a free vibration response of a single degree of freedom system. So what is a free vibration response? So by definition, so diba, if we have a building and then we applied a dynamic force on that building, the structure will deform. And by its elastic restoring force, it will eventually come back to its original position, but it will oscillate on the other end or on the other side. Diba? And then there will be vibration, there will be oscillation throughout the system. So mo to siya nga pag i-graph na to ang displacement, through time we will have this sinusoidal graph of the motion. So by definition, a free vibration response, there is no applied force. The applied force is equal to 0. So remember again that our formula for the equation of motion, we have the mass times the response acceleration plus the damping coefficient times the response velocity plus the lateral stiffness coefficient K times the lateral displacement is equal to the dynamic force P of T or the effective dynamic force P effective of is a function of time. For a vibration response to be called free or free vibration, there is no applied dynamic loading, then we arrive with this formula or equation. Let's say this is our equation 1. So mathematically speaking, this is a homogeneous differential equation. No, this is a homogeneous second order differential equation with constant coefficients. So this is homogeneous because this is set or equal to 0. So let's take a brief review of our basic mathematical concept. Let's take, for example, we have our first order differential equation. Here we have d over dt u of t plus k of t. So just don't mind your no sounding equation as something else. This is just a simple static differential equation. Aron mas masabtan ninyo, let's try the basic notations na ginagamit sa earlier years. This is just similar to dy over dt plus ky is equal to 0. where the y is a function. No? The y is a function. By our basic knowledge atong differential equation and basic mathematics, we can, by the additive property of equality, transpose this term on the right-hand side. So we will have dy over dt is equal to negative ky. And by the variable separable or separation of variables, we have dy over y is equal to negative kt. And if we integrate the left and the right hand side, we will get a solution of L and Y is equal to negative KT plus C. So dili lang no, ato lang ginagamit is instead of the U of T or instead of the Y or the X or the Z, we try to use U of T. So alam mo kalibog ana, eventually we will look at this solution. Now if we try to remove the natural logarithmic function here, we just add an exponential operation throughout the expression. So the natural logarithm and the exponential are inverse, so mura na siya makancel, then we will have y is equal to e to raised to negative kt plus c. Now, we can rewrite that one. The y is equal to e to the negative kt plus c can be rewrite by the property of exponent. No, if you remember, if you have x raised to n a multiplied to x raised to b, its exponents will just be added. So for this one, inverse lang atong gibuhat, that is just equal to e raised to negative kt times e raised to c. Since this is a constant, so take note that our c here is an arbitrary constant, and this side, the exponential of a constant will still be a constant. So if we say that our c naught or c sub o is equal to e to the c, then we will arrive eventually that y is equal to c naught e raised to the negative kt. So since atong gigamit nga variable here is the u of d, and then we will arrive at this specific solution. So maroon siya, basic lang siya na review, where our CO or C naught will be our arbitrary constant. So kabalo mo gitano in a differential equation, there are several solutions. First, we have the general solution and then particular solution. And in a differential equation, we have a family of solution. No? For a single differential equation nga gihatag, we can have a family of solutions here. So since this is the behavior for our first order differential equation, nga ang first order differential equation will yield an exponential function, we can also it can be shown also that the higher order differential equations are also in this exponential form. So we can also say that ang katong second order differential equation na ang solution have a exponential will be in exponential form. So mo na siya ang purpose na to ani nga review to determine the property or the behavior of its solution sa to ang differential equation. So let's review no another concept. We call this the superposition principle. So ano man superposition principle? So the let's say we have we have a differential equation. Buta na to sa inyo po dy over dt plus ky is equal to 0, etc. And then let's say that, so this is as a function of time, no? Let's add the function of time. Let's say that the y1 of t and y sub 2 of t are solutions to this differential equation. So na pananglitan na to kay daghan man og solution sa differential equation. Imutang na to nga si y sub 1 of t and si y sub 2 of d is solution sa usa ka ordinary differential equation. Now, saan man nato pag-apply ang concept ni superposition? Ingon niya, if nakay solution o solution 2 sa imong differential equation, if i-add na nimo ang duha ka solution, sa differential equation, that would still be a solution of that differential equation. No, so let's rewrite that as y of t is equal to the first solution plus the second solution. So the addition of two solution is also a solution. So muna siya ang constantly we have the superposition principle. Diba? So muna siya. So if you notice no, wala lang sa nato gi-add diri si constant kay well, mugawas na siya later on. So let's say no, we have the let's say no, nagmutan na to si constant lower no. So we have a solution of the differential equation, but we have arbitrary constant. So saan na to pag remove any arbitrary constant? So we have two unknowns. So sa pasabot, if we have two unknowns, if we have two unknowns, we require how many equations? We require at least two equations or conditions at least to solve or to find out what is this unknown variables. So saan na doon na pag-solve? So we already have our general solution na y of t is equal to c1 y of t plus c2 y of t. So to get this one, we need what we call the initial conditions. Diba? If you remember, to get a particular solution of your differential equation, you need initial conditions. So for this one, our initial condition will be what is the value of y at initial time, or let's say we call this our y naught, and then our second initial condition is that the value of y at time 1, or let's say this is our y1. Another way or another initial conditions na pwede na to i-apply is that, so we have here, the value of y at initial time for this example, let's say y dot, and then the value of the velocity or y dot at time is equal to 0 for initial time or initially is the y dot sub o. So what our calculation of for the equation of motion will be using this form in or the initial conditions in trying to solve the differential equation. So may concept ni superposition, if si differential equation na siya solution 1 or solution 2, and then if you add the solution 1 and the solution 2, that is still a solution of our differential equation. Now, adding the two general solution of the differential equation, naatay mga arbitrary constants. And then this arbitrary constant, so for this example, we have two arbitrary constants. To determine these two unknowns, of course, we need at least two equations to solve this one. So at those two equations, we try to have our initial conditions for this one, like this one, and then the other way is we get the condition or the function of, let's say for here, at time is equal to 0 or its initial position, and then we try to get the first derivative or its velocity when time is equal to or 0 or in initial time. So muna siya. So say let's say we have a differential equation y the prime minus 9y is equal to 0. And then, naa siya'y solution. Let's say it's y1 of t is equal to e to the 3t. So take note, na ang katong exponential form is applied on this one. So, di ba, tutong dissolve ang first order differential equation and it yield an exponential function. So, for this second order differential equation, we try to use that concept here. So, we have a first solution here. Y of t, we have the y1 of t is equal to e to the 3t, and then the y2 of t, its solution will be negative 3. So if you take the first derivative and then the second derivative and apply this concept, the answer will be equal to just 0. So, ingon din ni Kuan, di ba, sa tuwing giingon sa atong superposition, if you add these solutions, it will still be a solution of that differential equation. So we will have our initial boundary condition at time is equal to 0. So at time is equal to 0 na mas dali siya. So our y of 0 is equal to c1 e raised to 3 times 0 plus c2 e raised to negative 3 times 0. Of course, this is already an exponential function raised to 0 that will become to 1. So eventually, our initial condition y of 0 will just be equal to c1 plus c2. Next is it will be the first derivative. So we'll have y prime of t is equal to 3 c1 e to the 3t minus 3 c2 e to the negative 3t. And at time is equal to 0, y prime t 0 is equal to, we will have 3c1 minus 3c2. So this will become 1. That will become 1 also. So here we already have two equations. Y dot of 0 is equal to 3c1 minus 3c2. So eventually, we'll be able to solve this one. So napod din siya yung initial condition that at y of 0 that is equal to 2 and y dot of 0 is equal to negative 1. So this is equal to 2 and then this is equal to negative 1. So by elimination. So what do we do? If we, let's say, multiply this first equation with 3 para ma-eliminate si C2, we will have 3C1 plus 3C2 is equal to 6. And then on the other side, we have 3C1, this one here, below minus 3C2 is equal to negative 1. If we add these two equations, we'll have 6C1 is equal to 5. Or C1 is equal to 5, 6. Since na naman tayo C1, and kabalo mo nga C1 plus C2 is equal to 2, then eventually we will be able to get C2, which is equal to 7 over 6. So na naman tayo C1 and C2, then we can already have our solution. Y of t is equal to 5 over 6 e to the 3t plus 7 over 6 e to the negative 3t. So ang purpose lagi din no, usagid sa point ni superposition is that if a specific differential equation na siya duha ka solution here, for example, we have the y1t and the y2t, and then if you add those particular solutions, we will have still another solution to the differential equation. But this one, we have our arbitrary constant. So in order to solve the arbitrary constant, we have two unknowns. Therefore, we need two equations. So sa itong consider, we try to consider to solve the y as a function of time when the time is equal to 0. Same also with its first derivative at time is equal to 0. So mas na-simplify siya. No? Time is equal to 0. And then we arrive in this solution. And then by elimination, so we multiply this first equation with 3. And then by addition, we come up that C1 is equal to 5 over 6. And since na naman tayo C1, no, using this equation or either anong duha, kung pwede ninyo kung sa inyong type diya or style, then we can solve C2 with, here the solution is 7 over 6. And, substituting this solve values for our C1 or for our constants C1 and C2, then we have another particular solution of our differential equation. So, muna siya itong buhaton sa ato ang, what do you call this, ato ang, you have apply this concept in our single degree of freedom system.